Welcome you students. In this video lecture, we shall know about wedge friction. So this is the arrangement. The bottommost one is a wedge and this is a block. Wedge is a piece of metal or wood in the shape of prism whose section is usually triangle or trapezoidal. Okay, it is a prism which section is actually a triangle or trapezoidal. You can see here. Okay, fine. Actually, this wedge is used to displace or adjust a heavy load. Okay, it is used to adjust or just lift a heavy load. It is a block with a heavy load, and with the help of it, by applying the load just towards the left, just we can lift the block which kept above the wedge. Okay, so it's simple. Its purpose is to displace or adjust the heavy load. And when you are analyzing the forces acting on this wedge and this block arrangement, wedge weight is considered as a negligible. Okay, it's a very less amount. Okay, it will be very negligible amount. So it will be it won't be considered in the force analyzing. Okay, and this block, there will be a self weight. It will be a heavy and it will be considered. And the force applied to the wedge in order to lift the block will also be a very less amount, right? Fine. Here let us just try to know what are the forces just involved in this wedge and block arrangement, right? So for that, I just going to draw the wedge first. Wedge. So here in a freehand sketch, I just draw the wedge. So this is the wedge, and in order to get a better idea, I will just draw a cross line. Just consider it is XY so that you may get the exact force arrangements in a detailed manner. So this is how the X and Y, and here the applied force, which is P, okay, which is P. And listen, the bottom, the wedge has an contact with the surface, with the floor surface. Okay, so there will be a normal and friction force. Here the friction force, before that friction force we can place the normal. We know about the normal. Normal will be just acting inward and it will be 90 degree to the plane. So here 90 degree to the plane, I have placed the normal reaction, and friction force will be, can you able to predict where the friction force moves, whether in the right side or left side when you are having the contact in the wedge and the surface? I can say it will move in the right side. Why? Because the force is applied towards left. So motion will be just, motion of this wedge will be where? In the left side. So that the friction force will be in the right side. Have you got it? Move to the next contact surface. Here in the block and wall, there will be a contact. So, sorry, we are dealing with the wedge, right? So, I can say the wedge and this block will have the contact. So, and next, here in the wedge and the block, there will be a contact surface. So there will be a normal and friction force will be. If I place the friction force, I can say the friction force will be, the normal force will be just 90 degree to the plane. This is the plane, and it will be normal, which will be 90 degree to it. So this is the normal, right? And what about the friction? I can say the friction force, the same procedure which we have to take it in your mind. That means the motion is towards left, so that the friction between the wedge and block will be to the right side. So this will be the friction force. This is how the friction force will be. Okay, and whether we have the self weight, no, the wedge is a very negligible one, so self weight won't be considered here. And always remember, the wedge will have the angle alpha. Here it is mentioned, right? So this angle we call it as wedge angle, consider as a wedge angle. Okay, fine. And then move to the next one, which is a block. Here in the block, this is how the block is arranged. So I will draw it a free sketch. Okay, fine. And look at this. In order to understand, just I will draw a cross line, so that when you are analyzing the force, it will be better way to understand it. Okay, fine. Now, what are the forces? It has a huge weight, heavy weight. So block will have self weight, which will act from the center just downwards. Then if you consider the force between block and wedge, there will be a the friction force and the normal. Normal will be just 90 degree to the plane, so it is just a vertical line. So if you consider 90 degree, something like this, you will be having the 90 degree, which is a normal, And what about the friction? Where the friction moves? When you are giving the force to the wedge, this block tends to move in the right side. It comes just outwards, So motion is just outwards in this particular block, so that the friction will be inwards. So at that contact region, tangentially, you have to place the friction, which is just I can say moving in the left side. What about the next contact region, block and the wall? The block and wall, which also will be having the normal, which is 90 degree to it. Okay, normal is 90 degree to it, and then the friction for where it actually moves. Just imagine when you are applying the force, where this block will move. I can say vertically it moves. It tries to come out, at the same time it moves just up, right? So motion will be upward, so that the friction force will be just downward. It's a resistant force. Friction force is a resistant force, just opposite to the motion. So here will be the friction force. Okay, so now when you are analyzing, lot of friction and normal reactions are there. So in order to specify each one, just we can give namings. I going to start with this one, F1, N1, then this one is F2, N2, and see, this is the region between block and wedge. Here as well, it is a region with the block and wedge, so we can give the same name in the same spot. So here it will be N2 and F2, and here it is F3 and N3. Okay, so now we have given the naming. Naming is our wish, but I have started from this 1, 2, and this is 3, right? So now if you see, lot of friction and normal reactions are there. Okay, so when you are going with the problems, when you are analyzing to identify the force applied, it will be a risky task, and the steps will be very challenging and complicating to us. So we shall just reduce it by taking resultant force for this friction and normal. Okay, so we are taking the friction and normal a resultant force. So if I take the resultant force for the friction and normal, I can say here will be the resultant. So this resultant is R3, and it has been derived and it has been proven the angle between the resultant and the normal is pi, which is a friction angle pi. It is called as pi, which is a friction angle. Pi is a friction angle, and this friction angle formula is pi, which is equal to tan inverse of mu. Okay, tan inverse of mu. Mu is actually, friction angle is equal to pi, which is equal to tan inverse of mu, and this mu is a coefficient of friction. Coefficient of friction. Okay, so I hope you are getting it. Now, the same manner we shall also just take the resultant for this normal and friction. So if I take it here, you will be having the resultant or 2, and for the resultant and the normal, always keep remember the friction angle will be resultant and normal. So resultant and normal, it is a pi friction angle. And you may think, what would be the angle between the normal and this vertical component? Okay, so it's so simple. It is, the plane is inclined with alpha, right? With alpha wedge angle. Definitely this difference, this line, that means the force N, which is drawn 90 degree to the plane. So definitely the difference between this normal and this vertical component will show the wedge angle. That's a thing. Fine. So what about the next block? So here, if you consider for the N and F, here will be the resultant force or 2, and between resultant and normal, it is a friction angle pi, and this would be with a angle which is nothing but the wedge angle alpha. Okay, so here it will be the resultant 1, and between the normal and this resultant force is a pi. Got it? Okay, so it also we can give namings, differentiate with the pi. This is n3, n1, this one will be n pi 2, and this one will be pi 1. This is a pi 2. Okay, pi 3, pi 1, pi 2. Okay, so formula is friction angle is pi, which is equal to tan inverse of mu. Tan inverse of mu, it is based upon the coefficient of friction. Okay, if the coefficient of friction is equal in all surface, then mu1, which is equal to mu2, which is equal to mu3. Okay, it's a note. If coefficient of friction is not equal at the surface, at the contact surface, okay, then mu will be not equal to mu2, not equal to mu3. We have to find answer for each and every one. It will give mu1 a different, it will give the pi 1 a different one, and pi 2 a different one, and pi 3 a different one, since the mu1, mu2, mu3 are not equal. Okay, fine. Then just we have taken the resultant force for the friction and normal, right? So let us know how it is being reduced. So that I just going to take as a concurrent force something like this, the axis x and y, and now put the force here is the applied force P, and for this normal and friction, here it is been simplified as a resultant force 2, and with respect to the y axis, just look at this. If you want to represent with respect to the y axis the angle, then pi 2 plus alpha. Just keep remember it, pi 2 plus alpha, that's the thing. Okay, so if you want to take always with respect to this x axis, am I right? Always we will be resolving with respect to x axis the angle. So this angle, how we can calculate this angle? This overall angle is in 90 degree. So 90 minus, if you put pi 2 plus alpha, then you will get the answer for this. Okay, and then look at this. So here the resultant is moving something like this, which is R3, and this angle with respect to the vertical, which is pi 3, which is pi 3. Okay, any other force? No, only 3 force. So just resolving this wedge will be easier when compared to the before one. So number of force is 1, 2, 3 reduced. The similar manner, if you take for the block, this is the x and this is the y. So self weight will be acting, so that is W, I have been noted. And here the first quadrant, sorry, in the second quadrant there is a force, resultant force, which is R1, and with respect to horizontal it is being noted as pi 1. It is been noted as pi 1. And then here we have the force which is in the fourth quadrant, and the force is moving something like this. The force is moving something like this, and this is noted as R2. And with respect to the vertical, component, we have the knowledge, that means alpha plus pi 2. Okay, so here as well, see 1, 2, 3, 3 of the load or 3 of the forces are acting. So it also will be easier to move with the resolution of force method in order to solve the unknown present in this arrangement. Okay, so it is so easy, but we have to just simplify the force, that is the task. So if you understand this particular thing, it will be easier to resolve the problem to identify the force applied. And procedure in the problem will be by applying equilibrium condition, we will be moving with it. So method is the resolution of force method. Here sum of horizontal force is equal to 0 and sum of vertical force is equal to 0. This would be the step involved in the wedge friction. So I hope you understood what are the forces just acting upon the wedge and block, and how to analyze it, how to identify it, and what are the conditions are there, and in which procedure, by which condition we just following it. I hope you understood. Thank you so much.